Friends, we were going through the design of canal, in which we are designing the alluvial canal. So in the previous video, we have dealt with the design of alluvial canal by the Kennedy's theory. So today, we will be going through the design of the alluvial canal by the Lacey's theory. Okay. So before going through the Lacey's theory, if you are new to this channel, you can like, share, and subscribe this channel to your friends. And one thing you need to remember, that failures inspire winners and defeat losers. So this theory was put forwarded by Lacey. So he's a civil engineer of UP Irrigation Department that carried out the extensive investigations on the canals in alluvium. So he found that there were certain drawbacks in the Kennedy's theory, and he put forwarded his new theory. Okay. So he said that according to Kennedy, a channel is said to be in a state of regime if there is neither silting nor scoring in the channel. But Lacey came out with a statement that even through a channel showing no silting or scoring may actually not be a regime channel. Okay. He found the various drawbacks in the Kennedy's theory, like Kennedy did not suggest any equations for determining the bed slope. Likewise, Kennedy did not take into account of silt concentration and bed load, and Kennedy did not define silt grade and silt charge. Kennedy did not give his own flow equations. He used Cotter flow equations without any modifications. So these were the various drawbacks of Kennedy's theory. So Lacey put his own theory, and according to Lacey's theory, a channel is said to be in a regime channel or regime state in the following three conditions only. So if the three conditions are met, so he suggested that a channel is said to be in a regime state. So first is the channel flow in the unlimited coherent. So unlimited coherent is the soil composed of loose granular graded materials which can be scored with the same ease with which it can be deposited. So these are those soils that can be scored or deposited with the same degree of ease in both the cases. Okay. So he said that the channel flow in the unlimited coherent, incoherent, and also the second assumption is that the silt grade and the silt charge are constant. Likewise, the discharge is constant. So these were the assumptions of Lacey's theory. But in the actual practice, these three conditions are very, very, very difficult to achieve. So Lacey put forward his theory on the basis of initial and final regime of the channel. So friends, before going through the initial regime and the final regime, at first we need to understand what is the regime channel is. So regime channel is defined as the stable channel section whose width, depth, and the bed slope have undergone modifications by silting and scoring and are so adjusted that they have attained the equilibrium. Okay, so this is the regime channel in which the depth, the width, and the bed slope have changing or gone modifications by the process of silting and scoring, and they are adjusted in a manner so that they have attained the equilibrium. This is the regime channel. So friends, Lacey said that the channel has two regimes. So the initial regime and the final regimes. So initial regime is that when the channel attains the final section but doesn't secure its longitudinal slope, and it is the first stage of the regime. Likewise, the final regime is the regime when the channel attains the section as well as the longitudinal slope. So the section is recovered as well as the longitudinal slope. It is the ultimate stage of the regime attained by the channel, in which the bed slope, depth, and the width of the channel is suitably adjusted. Okay, so this is the initial and final regimes that Lacey demonstrated. So the certain assumptions that are made by Lacey are that first is that there is only one section and only one the longitudinal slope, that is the bed slope, at which the channel will carry the particular discharge with the particular silt grade. So he assumed that, he suggested that there is only one section. So only one sections that have particular value of the longitudinal or bed slope and with the particular bed width and the depth of the channel. So different sections cannot have different amount of silt grade. So different sections cannot have the same amount of silt grade as compared to the previous section. Two sections cannot have the identical properties. He suggested that. Likewise, the eddies are generated from the bed and from sides, both normal to the surface of the generations. Similarly, assume that silt in flowing water is kept in suspension due to the vertical components of edges. The vertical components of edges generated from side also helps in the support of the silt particles. Likewise, he introduced a term called a silt factors and related this silt factor with the average particle size. So these were the assumptions that are made by Lacey for the design of the alluvial channels. So he suggested that the edges are generated from the bed and from sides that are normal to the surface of the generations, and silt in the flowing water is kept in suspension due to the vertical component of edges, and the vertical component of edges from the side also supports the silt. So these were the assumptions that are made by Lacey in the for the design of the alluvial canal. So the equations for Lacey's theory. So Lacey forwarded his equations by the extensive study. Okay, so he first forwarded the formula for silt factor F, then can be given as silt factor F equals to 1.76 under root of d mm. So d is the diameter of the silt particles that is given. Okay, so in mm, so this diameter of the particles in mm. And second is the velocity v equals to 2 under root of 2/5 times the f into r. F is the silt factor and r is the hydraulic mean radius. Likewise, he also suggested third equation as af square equals to 140 v to the power 5. And he also related the velocity, mean velocity, with the hydraulic radius and the bed slope as v equals to 10.8 into r to the power 2/3 s to the power 1/3. So the symbols that are given in the expressions in the equations have their usual meanings. Now friends, so we'll be going through the various derived expressions and equations of Lacey's. So from the above expressions, from the above four relations, we can derive the various relationship among other parameters. So the first derived equation is between the velocity and the discharge parameter relationship. So when we have to determine the relationship between the velocity and discharge, we already know that the AF square equals to 140 b to the power 5. So if you just solve it, you can obtain b equals to f square by 140 to the power 1 by 5. So if you substitute the area of cross section as the discharge by velocity using continuity equations, you can easily obtain velocity v equals to qf square by 140 to the power 1 by 6. So this is the derived expression between the velocity and the discharge. Now the second derived expression is between the weighted parameter P and the discharge. So for the determination of the relation between the weighted parameter and the discharge, we know that B equals to root 2 by 5, the silt factor into the hydraulic radius. So if you just substitute the value of the hydraulic radius by the weighted area by weighted parameter or cross-sectional area by parameter, so you can just simply put R equals to A by P here. So if you again here you need to know, you have to convert everything, all the expression into the term of the parameter and the discharge. So you have to substitute the value of the area in terms of the discharge. So you can substitute area A as Q by V. Okay, and you can again substitute the value of the silt factor F using expression AF square equals to 140 V to the power 5. So if you solve that, AF equals to 140 V to the power 5 by A to the power 1 by 2 will be the substitution value. If you substitute this and solve this, you will be easily obtaining P equals to 4.75 root Q. So sorry, P equals to 4.75 Q. So this is the expression for the weighted parameter and the discharge. So the third derived expression is the bed slope equals to 1 by 4980 cubed through under root F cube by R. So S fourth is the S equals to 1 by 3340 times F 5 by 3 divided by Q 1 by 6. Likewise, the hydraulic radius R can be expressed in terms of discharge and the silt factor as R equals to 0.47 Q by F to the power 1 by 1/3. So likewise, if you convert this hydraulic radius and discharge in terms of specific discharge, that is Q by B, you can obtain the hydraulic radius R equals to 1.35 Q square by F 1 by 3, where your small q is the specific discharge, that is the discharge per unit width of the channel. And at last, you can also relate the hydraulic mean radius in terms of velocity, mean velocity and the silt factor as R equals to 5 by 2 into V square by F. So these are the Lacey's, some of the derived expressions and equations. Now friends, we will move through the design procedures of the alluvial canal by the Lacey's theory. So at first, we need to calculate the silt factor by the given particle size. Okay, so using the formula F equals to 1.76 under root D, that is in mm. So the diameter of the particle, the size of the particle is given in mm. So you can calculate the silt factor. Okay. After that, the next step is to calculate the velocity. So using the expression V equals to QF squared by 140 to the power 1 by 6. So this is the expression with which you can calculate the velocity. Generally, this discharge will be given in the question. So you have obtained the silt factor and the discharge is given. So you can determine the velocity easily. Likewise, the next third step is to determine the area. So using the continuity equation. So you can use Q equals to AV and you have already find the velocity. Okay, and your discharge is already given in the equation and you can easily find the area of cross section of that channel. Likewise, in the fourth step, you need to calculate the weighted parameter using the length of the linear waterway. So using the parameter, using the parameter P equals to 4.75 root Q, you can easily find out the parameter. So as discharge is given in the question, so it will be generally given in the question, you can easily find the parameter here. So after determining the parameter, so you need to determine the bed width of the channel and the depth of the channel, assuming the suitable and appropriate bed slope. So you using the appropriate bed slope according to the soil characteristics, you can determine the bed width and the depth of the channel. Finally, you need to determine the bed slope using the formula bed slope S equals to 1 by 3340 into F, that is silt factor to the power 5 by 3 Q to the power 1 by 6. So using this expression, you can easily find the bed slope. Here you already know that is silt factor F, and you know the discharge, so you can easily find out the bed slope using this expression. Now friends, we need to design a regime channel for the discharge of 40 Qmac and the silt factor of 1.2 using the Lacey theory. So we have the problem here, design a canal of having discharge 40 Qmac cubic meter per second, having silt factor 1.2 using the Lacey theory. So we need to proceed. Now friends, the given is the discharge and the silt factor. So step 1 is to find the silt factor. As the silt factor is already given, that is 1.2. So we need to proceed to step 2. Now in step 2, friends, we need to use the formula for the velocity. V equals to QF square by 140 to the power 1 by 6. So if you substitute the value of the silt factor as 1.2 and the discharge is 40 Qmac, so you can easily obtain the velocity V as 0.862 meter per second. Now friends, in step 3, we need to determine the area of the cross section using the continuity equation. We can find A equals to Q by V. Here substitute the value of discharge and the value of velocity obtained in previous step. We can easily obtain the value of the cross sectional area as 46.40. Now friends, in this step 4, we need to find the weighted parameter P. The weighted parameter P can be easily find out using the formula P equals to 4.75 root Q. Now substituting the value of Q, we can easily obtain parameter P equals to 30.042 meters. Now friends, in step 5, we need to determine the value of the bed width and the diameter and the depth of the channel. So for this, we assume the trapezoidal canal having side slope 0.5 horizontal used 1 vertical. Okay, so we need to apply the formula for the weighted parameter and weighted area. That is parameter P equals to B plus 2D root over 1 plus Z square. This is for the trapezoidal section. So if you substitute the value of the parameter, you can easily find the expression in terms of B, that is B equals to 30.042 minus 2.236 times D. This suppose maybe this may be your expression 1. So likewise, you can write the area as A as BD plus ZD square. So you know the what is area as determined from the previous step. So you need to substitute the values of area and you need to substitute the B. So you need to substitute the bed width from expression 1. Okay, now then you will obtain the equation in the form of quadratic equation. So solving this quadratic equation, you can easily find out the depth of the canal as first value you will obtain as 15.590 meters and second is 1.714 meters. So that D1, that is 15.590 meters depth, is very impracticable for use. That is very huge depth. So we just assume that the depth of the channel is 1.714 meters. Okay, so we now the correct depth of the channel is 1.714 meters, and substituting this depth we will obtain the value of the bed width as 26.20 meters. So friends, in step 6, you need to find the bed slope. So you can find the bed slope using the simple expression S equals to 1 by 3340 into F to the power 5 by 3 Q to the power 1 by 6 divided by, okay. So if you substitute the values of the silt factor as 1.2 and the discharge as 40, you can easily find the bed slope as 1 in 4558. So this is the required expression of the bed slope, 1 in 4558. Finally, you need to provide your design that you need to provide a trapezoidal channel section of side slope 0.5 used to 1, having the bed width as 26.20 meters, the depth as 1.714 meters, and the bed slope as 1 in 4558.
So friends, if you find this video as useful, you can like and share to your friends. And for such videos, stay tuned to this channel. Thank you. We will meet soon in another video.